learners, welcome to Education Online program. So in our previous lesson we learned about the gas laws, which we talked about the Boyle's law, the verification of Boyle's law using an experiment, where we said also you can try it at home using a syringe, so don't forget to try that. Then we have the Charles law. After the Charles law, what happened is that when we tried getting the values during the experiment of Charles law, we got two graphs. The graph of volume against the temperature, but in Kelvin, and then there was the second graph of volume against temperature, but then measured from the Celsius scale. So on that graph, what happened is that we had something, okay, we had two graphs like this. Okay. Was our first graph of volume against the temperature. That was the volume, which was measured in centimeters cubed, and then the temperature, this we were measuring it in Kelvin. So when you measured using the Kelvin Celsius scale, we had a straight line from the origin. But then it was not the case with the graph of the volume against temperature from the Celsius scale. We had this kind of graph. So this is our volume measured in centimeters cubed, and then we had the temperature measured in Celsius, degrees Celsius. So the graph, we had a straight line, but then it was not from the origin, but then it came and stopped at the axis here. Then when we try to pull this back to measure the temperature there, we got it as -273. Yet this is the origin. So we are saying that these two verify the Charles law. But then what do we call this temperature is what we are to see today. So this temperature here at this point of 273 is what is known as the absolute zero temperature. This is the absolute zero temperature. What is this absolute zero temperature, and why is it that at this point, when you're using the Celsius scale, you do not get a straight line from the origin, but instead when you try to you get what is known as the absolute temperature, zero temperature. So if we look at the absolute zero temperature, this temperature here coincides with a zero temperature mark from the Kelvin. So you see that when it reaches this -273 on the Celsius scale, it is the same as the zero on the Kelvin. So meaning that when the gas has attained this, it means that the gas will have volume that is zero at this temperature. If our volume at this temperature is zero, is it possible for the gas to go totally to to zero volume, to have zero volume after compressing. So you see that after compressing the gas, it is not that it has to shrink totally to zero. This is because these gases, they first liquidifies. So when it liquidifies, then what happens? It will then turn to solid. That means that it will freeze in order to attain the solid state. So at this point, how would you now convert this Celsius to Kelvin? To convert it, now you have to be using this figure, this temperature 273. So it will be giving us, if you get any temperature and add this to it, it will now give you the reading on the Kelvin scale. So we can say that the absolute zero temperature is we can define it there. The absolute zero temperature of 273 degrees Celsius is the temperature by which the volume now of the gas becomes zero when it is cooled. So whenever you're cooling your gas, it attains this kind of temperature when the gas is attaining a zero volume. So I am saying that the gas cannot go totally to zero because it will first liquidifies. So when it is liquidified, it will then turn into solid. So let us see if we have a temperature on the Celsius scale. How can we convert it to the Kelvin scale? So let us look at the conversion of Celsius scale to the Kelvin scale. For instance, let us say if we have a question like we have a temperature of -73 degree Celsius. We want to convert this to the Kelvin scale. To the Kelvin. So what do we do here? For you to get the real temperature on the Kelvin scale from the Celsius, you just get the temperature you were given in Celsius, then add the absolute zero temperature to the temperature you're given, and then the result will give you the what? Will give you the reading that is supposed to be on the Kelvin scale. So at this point here, our temperature will be equaling to this temperature that has been given to us, which is -73. Then we shall add the absolute zero temperature, which is 273. So this time round we are we are converting this to Kelvin, because we said at this 273 degrees Celsius, the Kelvin scale will give you a reading of 0. So if we have it like that, our temperature on the Kelvin scale will read as, if we get your 273 and then you add negative 73, it is more or less like subtracting 73 from the 273. So we shall have 200 Kelvin. So this is how we can convert. This is how we shall be converting our the Celsius scale to the Kelvin. So when they have given you the temperature in Kelvin, you can just use it direct. But if it is in Celsius, then we can convert it to Kelvin using this formula there. So let us look at one example on the Charles law. So we have it that the volume of a fixed mass, the volume of a fixed mass of a gas is directly proportional to its absolute temperature. The volume of a fixed mass of a gas, that is not the question. We're saying the volume of a fixed mass of a gas at constant. This is supposed to be at constant. Can have at constant pressure is 400 centimeters cubed at a temperature of negative and 73 degrees Celsius. Calculate the volume when the temperature is raised to 27. When the temperature is raised to 27 degrees Celsius. Because we see that we obtain our absolute zero temperature from the graph when plotting the volume against the temperature. Because with the Charles law, we say that the temperature and the volume of the gas are proportional to each other, but then keeping the pressure constant. So if we are keeping the pressure constant, we just vary the temperature and then the volume. How do they vary? You see that we got the absolute temperature, zero temperature on that scale. So during our conversion, we shall be using the absolute zero temperature so that we can convert it to the Kelvin scale. So the question is saying that the volume of a fixed mass of a gas at constant pressure is 400 centimeters cubed. So the volume here that is the first volume of the gas. Before you maybe adjusting, we had the first volume as 400 centimeters cubed at a temperature of 73 degrees Celsius. So the first temperature we obtained was negative 73 degrees Celsius. Now the question wants us to calculate the volume when the temperature is raised. So what will we have as our volume of this gas again when the temperature this time is varied from negative 73 degrees Celsius to 27 degrees Celsius? So to find this volume here, we need to to find this volume, we need to first convert the temperature we want to measure it in using the Kelvin scale. So for the first temperature, we obtain negative 73 in the Celsius scale. How do we convert that? So to convert this, we shall have, that means our T, the temperature, will be equaling to the negative 73 plus the absolute zero temperature, which is 273. So there our temperature will give us, instead of negative 73, we shall have 200 Kelvin. So now let's go to the second. We have it in degree Celsius. We also convert that to the Kelvin scale, so that we shall have our second temperature will be equaling to 27 plus 273. What will it give you? If we have 273, then we have 7 under it. 3 plus 7 will give us 10. So we write our 0 and carry 1. We have 7 plus 2. That will give us, we have 7 plus 2 will give us 9. But then we also have the 1 that has been carried. So we shall have it as 10. So we shall write 0 and carry 1. So we shall have 1 plus 2, which will give us 3. Meaning that when we add 27 to 273, we shall have a temperature of 300 Kelvin. So the question did not tell us to find the temperature. What we have been doing is converting the temperature from the Celsius scale to the Kelvin scale. Now the question is telling us to find the volume. So how do we find the volume when of this gas when the temperature has been raised to this value? So from Charles' law, what we say that the volume of a fixed mass of a gas is directly proportional to the temperature, keeping the pressure constant. So our formula was from P, pressure, product of pressure and volume, which is equals to the constant temperature. This was from the Boyle's law, where the temperature is constant. Now let us try to get the formula we are supposed to use for the Charles' law from Boyle's law here. So if we have it like that, at this moment we want to make the pressure to be constant. So we are going to make our pressure here the subject. So we shall have our V dividing it by T will be equaling to the pressure, which is constant. So if the pressure is constant, that means the variation will be for volume and temperature. So even if, if you change the volume here, it will still give you a constant volume that side, and then it will give you another constant volume over temperature, then the pressure. So it will continue like that. But in this case, we just varied it twice. So we shall have this as our V1 and then T1. So we have our, this is our V2 and then the T2. The T2 gives us the second temperature. So now from our formula that is saying the V1 over temperature 1, which will give us a volume 2 over temperature 2. Here our value of the volume of this gas at first was 400 centimeters cubed. So we shall have 400. At what temperature was the volume? 400. So it was at the temperature of 200 Kelvin. So we shall have it here as 200 equaling to the volume now. Again, the volume the gas attained after the temperature rise is what we want to find. So what was the temperature rise? It was 27 degrees Celsius, but on the Kelvin scale, it is 300 Kelvin. So we shall have it here as the volume we want to find over the 300. So we shall have it as, you can divide through, this can divide with that, this you can divide through, and then we shall have 2 goes here once, and then 2 goes here twice. So you'll see that 400 divided by 200, we shall have a 2 here, which will be equaling to our V divided by 300. So what do we do there? We make our 2, we change it into a fraction. How can we change it into a fraction? By dividing it by 1. Because if you divide any number by 1, it is more or less like the whole number. It does not change anything. So we shall divide here by 1 in order to cross multiply. So when we cross multiply here, we shall have 2 times 300, which will give us equaling to the 1 times the V will give us the V2. So when you get 2 times 300, what shall we have? We have our 300, and then we are multiplying it by 2. So 2 times 0 will give us 0. 2 times 0, which is 0. 2 times 3, this will give us 6. So that means that when we get 2 multiply it by 300, we shall get 600 here is equals to V2. So what is the SI unit of volume? Because here we are trying to find the volume here. So we shall have it as 600 centimeters cubed. So you see that when you increase the temperature of this gas from negative 73 degrees Celsius to 27 degrees Celsius, what happens to the volume of this gas? You see that at first the volume was 400 centimeters cubed. That was before you varying its temperature. So after varying the temperature, you come back and check the result. You see that you increase the temperature to 27 degrees Celsius. Also here, the volume of the gas was increased. And it was increased to what? Instead of us having still 400 centimeters cubed, we are having 600 centimeters cubed. this alone from the calculation verified the Charles law. So you'll see that with Charles law, whenever you increase the temperature of the gas, you will also you're increasing the volume. How does the volume increase there? This is because there will be expansion of the gas. Since we know that from kinetic theory of matter, these molecules have got forces of attraction between them. So when the gas absorbs the heat, this heat that it absorbs goes and breaks that force of attraction in between them. So when the force is being loosened, you see that the molecules have enough, they move randomly and they can occupy more space than before. So you see that they expand. That's why you see that whenever you increase the temperature, the volume also increases. So what if now you reduce the temperature of the gas? What will happen to its volume? The volume will also reduce, on a condition that you kept the pressure constant. If you also kept varying the pressure, that means you're not verifying the Charles law. There you'll be verifying the Boyle's law, because there it is the temperature we kept constant. So every time you reduce the temperature, you'll be reducing also the volume. So that is the logic behind the Charles law. So with Charles law, you remember to always convert your Celsius degree to the Kelvin using the absolute 0 degree temperature. So with this, we come to the end of our lesson. We shall meet again with another gas law, which is known as the pressure law, in our next lesson. Thank you very much for attending the lesson. We meet again. Bye.